Alright, so section 5.2, we talked about adding, subtracting, and multiplying polynomials. This section is on dividing them. And there's kind of three types of division. There's the basic type of division, which is number 9, and then long division and synthetic. So here's the basic type. We'll do 2x to the 4th plus 3x cubed plus x squared, and we're dividing this whole thing by 3x cubed. That just means dividing each of these terms individually by 3x cubed. Basically, you can split each of these down the middle and put them all over 3x cubed. That's what we'll do. And then from this point, we just apply those laws of exponents that we talked about before. So 2 over 3 stays the same, and we subtract those exponents, we would get x to the first. So that's the first term. This is 3x cubed divided by itself, that's just 1. And then here, that's a 1x squared, so our fraction is going to be 1/3. And then we do 2 minus 3, we get x to the negative 1. Remember, having a negative exponent, that's the same as flipping it to the bottom of the fraction. So now it's on the bottom, and it becomes positive. And that is our simplified answer right there. How do we do long division? We would take 3m minus 1 right here, and we will put that, this thing in parentheses, or not in parentheses, but under the division bar. We need to make sure all the powers are covered, so m fourth, m to the third, m to the second, m to the first, and then the number. If any of those were missing, we'd have to put a 0 times the coefficient. And now what we ask ourselves is basically how many times does 3m go into each of these? So how many times does 3m go into 3m to the 4th? Well, that's going to end up being m cubed, so this will go right there. Then we multiply m cubed by each of these. So 3m times m cubed is 3m to the 4th. M cubed times negative 1 is minus m cubed. This is a good sign. If these powers are lining up, m to the 4th, m to the 4th, m to the 3rd, m to the 3rd, that's a correct sign that we're doing it right. Then we subtract these, just cancel. 2 minus negative is like 2 plus, so 2m cubed plus 1m cubed is 3m cubed. We bring down the next term. How many times does 3m go into 3m cubed? It would go in m squared times that is 3m cubed, and then m squared times the minus 1 is minus m squared. Subtract those cancel. 2 minus negative is like 2 plus again. Let's move this up so we have a little bit more space. 2m squared plus m squared is 3m squared. Bring down the minus 7m. 3m goes into 3m squared m times. So m times each of those things we're dividing by. M times 3m is m squared. M times the negative 1 is minus m. Subtract those again, so those cancel. Negative 7 minus negative is like plus. That would be negative 6m. And we'll bring down the last term right here. 3m goes into negative 6m negative 2 times, and then negative 2 times 3m is negative 6m. Negative 2 times negative 1 is plus 2. And then we'll do our last subtraction here, so we're going to have those cancel, and then 3 minus 2 is 1, that's our remainder. There's nothing else to bring down, so we would write our final answer as this whole thing plus remainder 1 over 3m minus 1, and that is a simplified answer. Okay, the thing about synthetic division is it only works when it's x being raised to the first power. If it's something else, like if it's x to the second, x to the third, you have to use long division. Okay, so let's set this up. So first, when we do synthetic division, we need to put the number here that represents x plus 3, and that's whatever number is going to make x plus 3 equal to 0. The only thing that would make that 0 is negative 3. Then over here we need to fill in our coefficients. So what coefficient goes with x to the 4th? That's a 2. X to the 3rd, that's a 4. X to the 2nd, that's a negative 6. There isn't an x term, so we need to put a 0 right there. And then negative 2 is the term that's just a constant. How does synthetic division work? You add these columns, and then you multiply the numbers on the bottom. So 2 plus, there's nothing there, so 2 plus 0. 2 plus nothing is 2. 2 times the negative 3 is negative 6. We add those to get negative 2. Negative 2 times negative 3 is 6. Add those to get 0. 0 times negative 3 is 0. 0 times negative 3 again is 0, so we get remainder negative 2. So here's what happened. We had x to the 4th, we divided it by x to the 1st, and we get a depressed polynomial. That's what that's called. Each exponent is depressed by 1. So x to the 4th becomes x to the 3rd. x to the third down here becomes x squared. These really don't need to be here. And then we have remainder -2. So our final answer is 2x cubed minus 2x squared. Remainder is -2, so minus 2 over what we divided by. And that's what we divided by. So that goes right here. And that is our answer using synthetic division. And when it says evaluate a function, that's just another way of saying find the value. So w of n is this thing, and what they're telling us here is evaluate w of n plus 2. So that means wherever I see an n, and I see an n right here, wherever I see an n, I'm going to plug in n plus 2. So let's simplify that out. Remember that we're not solving anything on this side. We don't touch anything there. It's just another way of saying plug in n plus 2 for this, for n. We don't actually solve anything with w. W is just there as a placeholder, where it tells us it's a function. Okay, now squaring this means we FOIL it, so n times n is n squared. Outer terms is n times 2, which is 2n. Inner terms is 2 times n, which is also 2n. 2 times 2 is the last terms, that's 4, and we still have this minus 4 here. So 4 minus 4, those cancel, and 2n plus 2n is 4, and so the final simplified version will be this right here. Let's just check to see if we got it, and that's right. To describe the n behavior, there's really only two things you need to know for n behavior. Two graphs. You need to know what this graph looks like, which is a parabola, and you need to know what this graph looks like. This is the cubic function. Starts out looking like a parabola, very similar, and then this goes this way. N behavior means what does the graph do as x goes to infinity in either direction. So since this right here is x to the 5th, the leading term is x to the 5th, it's going to look like this one. If there had been a negative in front of that, it would flip this. So the negative version, if you put a negative, it would kind of go down like this. But that's obviously not the case here, so we don't need to worry about that. What's the n behavior? Well, notice on this side of the graph as x is going to positive infinity, it's going to infinity on the right side of the graph. This is positive infinity this way. As x is going to positive infinity, this function, this line, is going upwards forever, which means it's going to positive infinity. So let's see if we can narrow anything down. As x goes to positive infinity, f of x goes to positive infinity, that's still an option. This one is wrong because it's saying it's going to negative infinity. That's not true. So b is crossed out. Okay, as x goes to positive infinity, f of x goes to positive infinity, that's still possible. This one is also wrong. It's saying it's going to negative infinity. Okay, second part of the graph, as x goes to negative infinity, that's on this side of the graph. The left side means going this way, x is going to negative infinity. Where is this yellow line going? Well, the function is pointing down forever, which means it's going, these y's are going down, they're going to negative infinity. So which one is out of A and C? As x goes to negative infinity, f of x is not going to positive infinity, it's going to negative infinity. So it has to be option C. Okay, 5.3, I think this is the last one from 5.3. Sketch the general shape. Well, we just said that x cubed looks like this. That's the general graph of x cubed. This negative in front basically flips it, so I'll do the flipped version of this in red. This is going to take this and flip this one over that axis, and it'll flip this one over that axis. This one is definitely wrong because that's a parabola. That has to be something with x squared. This has the n behavior of a parabola. It's probably something like x to the 4th. This would be like regular x cubed. This is the only one that works right here. And it's a little bit distorted, like it doesn't look exactly like mine because this other things push the graph upwards, but that's the same n behavior. Okay, so that is 5.2 and 5.3. In the next video we'll talk about 5.4, which is more on graphs.